Have you ever just stopped and wondered how a machine can possibly understand what it sees? I mean, it's one of the most incredible achievements in modern AI. And today, we're going to pull back that curtain and see exactly how it all works.
I mean, think about it for a second. This isn't science fiction anymore, right? Your phone knows your face. Your photo library automatically tags your friends. Cars are navigating busy streets. We are literally surrounded by machines that can see and interpret the world. But how do they go from just being a camera to having actual, understanding?
Well, the entire foundation of computer vision, all of it, rests on one single revolutionary idea that any image, no matter how complex, can be broken down into a universal language of numbers that a machine can actually learn to read.
Okay, so look at this picture. When we look at it, our brains just instantly get it. We see a dog, we see the fur, the eyes, the snout, we get the whole concept of dog. But a computer? It doesn't start with any of that context. It doesn't see a dog at all. To a machine, this image is absolutely nothing more than a giant grid of pixel values, just a sea of numbers, where each one represents the color and brightness of one tiny little dot. So the huge fundamental challenge is, how do you teach a machine to find meaningful patterns, like the shape of a dog, inside that chaos of numbers? The brilliant solution is a technology called a convolutional neural network, or a CNN for short. Now, these are a special kind of AI, kind of inspired by our own brain's visual cortex, and they're designed specifically to take that chaotic grid of numbers and, layer by layer, pull real meaning out of it. And hey, this isn't some brand new idea. The groundwork for this was actually laid way back in 1998 with something called LeNet-5, which was amazing at reading handwritten numbers. But the real explosion, the moment everything changed, was in 2012, when a model called AlexNet just completely dominated a massive image recognition competition. That moment kicked off the entire modern deep learning revolution.
So how does a CNN actually pull this off? Well, the core logic is surprisingly elegant. It really relies on two key building blocks, two special kinds of layers that do very different but totally complementary jobs.
All right, first up is the real star of the show, the convolutional layer. The best way to think about this layer is like a team of super specialized detectives, and each one is looking for just one specific clue inside the image. So here's how it works. Each one of those detectives is called a filter, and it's just a tiny grid of numbers that's set up to spot one simple pattern, like, say, a vertical edge. This little filter then scans across the entire image, sliding over every single spot. And every time it finds a match, it makes a mark on a new map called a feature map. So what's the result? A brand new image that literally lights up to show you exactly where all the vertical edges are. And this is the most powerful part of the whole thing. We don't have to manually program these filters. We don't have to tell it, hey, look for edges, look for curves. During its training, the network automatically learns which patterns are the most important ones for identifying an object. It literally teaches itself what to look for. It's incredible. Okay, so we found our basic patterns, but this creates a ton of really detailed information, maybe too much. And that's where our second key player comes in, the pooling layer. Its entire job is to step back, look at the feature maps we just made, and just summarize them. You can think of them as the perfect team. The convolutional layer's job is to find every single possible clue and make a super detailed map. Then the pooling layer comes in, and its job is to simplify that map, keeping only the strongest, most important clues. It makes the whole process way more efficient by shrinking everything down while holding on to the most important bits of information. Now, one of these layers on its own is useful, sure, but it's not revolutionary. The true genius of a CNN is what happens when you start stacking dozens or even hundreds of these convolutional and pooling layers, one right after the other. Because by stacking these layers, the network creates what we call a hierarchy of vision. It starts with the absolute basics and then builds its way up to incredibly complex ideas, which is, a lot like how our own brains work. So let's go back to our dog again. When that image first enters the network, those initial layers, they don't see a dog at all. Their simple little filters are just hunting for the most basic building blocks possible. Simple edges, changes in color, and really primitive textures, like the pattern of fur. So the output from those first layers, the maps of all the edges and textures, that gets fed into the next set of layers. And these layers start combining those simple patterns into slightly more complex concepts.
Now they're starting to see things like corners, curves, and basic shapes just by putting those simple edges together.
Go even deeper, and the next layers take those simple shapes and combine them. So now the network isn't just seeing lines and curves anymore, it's starting to recognize actual object parts. It's identifying the distinct shape of an eye, or the floppy curve of an ear, or the line of a snout. And then finally, at the very end of the network, the last layers take all these identified parts, the eye, the ear, the snout, the fur texture, and they put them all together to make one final classification. It is learned that this specific combination of features means dog. So this whole hierarchical process is just incredibly powerful. And to see how it performs in the real world, researchers love to test these networks on standardized challenges. Let's take a look at a classic example. This right here is the CIFAR-10 dataset. It has thousands of tiny, low-res images across 10 different categories. And as you can probably tell, it's pretty tricky. You've got cats and dogs that look similar, objects at weird angles, cluttered backgrounds. This is the perfect test for a CNN's ability to learn what really matters in an image. And you know what's so amazing about this? Building a network that can solve this complex visual puzzle? It doesn't take thousands of lines of custom code. With modern tools that we have now, a developer can define one of these incredibly powerful networks in just a handful of lines. It's wild. So let's just zoom out for a second and look at the big picture. What are the key takeaways here? Well, first, CNNs learn which features are important automatically. No hand-holding needed. Second, they build understanding in a hierarchy, going from simple lines all the way up to complex objects. And finally, this elegant architecture. It's the foundation of pretty much all modern computer vision. So we've done it. We've successfully given machines a form of sight. They can classify and detect things in the visual world with incredible accuracy. And that really leaves us with a fascinating final thought. Now that they can see, what's the next great frontier? What will they learn to understand next?